Hey guys, so we're doing a covalent bonding diagram today, and our molecule that we are going to draw is oxygen of the formula O2. In order to draw an oxygen molecule, we need to figure out the number of valence electrons in the outer shell or outer shells of the atoms, that is the elements present in one molecule of O2. So if we have an oxygen atom should have 6 valence electrons in its outer shell. Since we have 2 oxygen atoms, we should really have 6 by 2, which is 12 valence electrons in total. Now that we have calculated our total number of valence electrons, we're going to go back to our molecule and try to figure out its structure. If we have 2 oxygen atoms, it makes sense that they would be bonded to each other. So I'm just going to draw the symbol for our oxygen atoms. I am not going to draw the other electrons present in the atom. We are only looking at the outer shell, which is the valence shell. So if we have 12 valence electrons in total and our 2 oxygen atoms have to bond to each other, it means they must bond by at least one single bond. And if they do so, that means to bond by one single covalent bond, it means this is one bonding pair, which is equal to one shared pair of electrons, which is in total 2 electrons. So if we deduct 2 electrons from our 12, we are left with 10 electrons. So let's draw it in. So I'm drawing in my 2 electrons here, and we are left with 10. That means 5 on each atom. So just for the purpose of drawing, so let's draw in our 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is our structure correct? We look at it. So we have 2, 4, 5, 6, 7 electrons around each oxygen atom. And we know that our structure is not correct because when a non-metal bonds via covalent bonding, it does so to attain the stable electronic configuration of the noble gas closest to that element in the periodic table. So oxygen needs to have a total amount of 8 electrons in its outer shell. So that means we have to try again. So we're going to erase. And if I didn't mention it before, drawing a covalent bonding diagram is a process of trial and error, which becomes easier with practice. So let's try again. So if it is that one single bond was insufficient, we are going to draw 2 bonds. So these 2 bonds together here means that we are looking at 2 bonding pairs adjacent to each other, and the 2 bonding pairs, which are called shared pairs, come up to a total of 4 electrons. So we are going to draw in our 4 electrons, our dot and cross here to represent the 2 shared pairs or 2 bonding pairs, and we are going to deduct that from the total number of valence electrons that we calculated, which gives us 8 valence electrons remaining around our atoms in our molecule. So if we have a total of 8, that means it's going to be 4 for each oxygen atom. And because it is 4 for each oxygen atom or 8 valence electrons, this should come up to a total of 4 lone pairs, or what we call non-bonding pairs. So because it's 4 in total, that means 2 per oxygen atom. So 1, 2, 3, 4, which gives me 2, 4, 6, and 8 valence electrons in total. Now, do we know if our structure is correct? We go and calculate the number of electrons in the outer shell of each atom, and it comes up to 2, 4, 6, 8. Therefore, this is the covalent bonding diagram for oxygen. And in looking at our molecule, let's keep in mind where we have 2 covalent bonds between 2 atoms, this is called a double covalent bond. Okay, thank you for viewing.